Hello, everyone, and welcome to this brand new series on how to reverse some of our various network protocols. Now, today we're looking at spanning tree. So, I have a simple topology over here. Now, over here, I have my Kali machine connecting to this switch on this port, and I have a WebThem PC, which is a container, a browser container, which is going to access this WordPress server. Now, on the switches, switch 1 is the show spanning tree. Switch 1 is the root for VLAN 1, as you can see is there. Now switch 2, we'll see switch 1 as the root bridge through the port Ethernet 0/0. Same applies to switch 3 over here. Right, so now my browser PC is able to access this WordPress server, and as you can see, it's working. So let me initiate a continuous ping. All right, the IP address, yes. So the pings are going through now. So on my Kali machine, I assume that I'll plug my Kali machine to any access port. Now on switch 2, show interface E0/1 switch port. Shows me that DTP is running. We can disable DTP, but it wouldn't change anything. It's in static access, and we are currently tracking in VLAN 1. That's fine. I also have port fast enabled. Okay, so now back on my Kali machine. I'm going to start Wireshark. So let's wait for Wireshark to start. It's now loading. And let's filter for spanning tree. So of course, you're going to see spanning tree packets flying through our interface on the Kali machine. As you can see, we have the bridge identifier and the root identifier. They have their values. Now, what I'm going to do is I'm going to capture the packet with scapy. Okay, so I have a script here. First, I'll copy this one for you to see. So I'll go back to my terminal, paste it in, and I'm going to, okay, so first of all, I have to start scapy, otherwise it will not work. So let me run scapy real quick. Okay, so now we have scapy running. So now I'll paste it here. So we are sniffing for STP traffic. Now the MAC address you see over here is the well-known MAC address for spanning tree. So I'm going to show it or display the packet that I captured because the sniff command was stored in a variable. So pkt index 0, that means the first packet dot show. And as you can see, I can see the spanning tree information over there. I can also type packet 0 index 0. So the first packet, and then you are looking for STP. Okay, so let me type STP capital letters. And as you can see, we get it right over here. So now let me switch to my script. So basically what the script is going to do is I'm running the script in Python 3, and I'm importing all from scapy, and I'm going to sniff only one packet, and I'm going to change the path codes that packet that we captured, the path cost, we are changing the path cost to 0, and then we are changing the bridge of the bridge mark of that particular packet. So let me okay. So we are changing the path cost to 0 here. The path cost to the root bridge is 100. We are changing to 0, and then the mark, we are changing the bridge mark of this particular packet to the root mark. Now that will make the switch to assume that our Kali is the root. Okay, and then this is the port ID. We are changing it to 1. So that's some of the characteristics of spanning tree: the root, the path cost, the mark, and then the port ID. And then we are going to loop and send this packet back. So basically, what we are going to do is that we are going to capture a packet spanning tree related, and then this machine will just re-engineer the packet and send it back into the network, and it's going to think that the Kali is now the root, and it's going to loop for a number of times. So for as long as it loops, it's going to switch 2 here is going to assume that this is the root, right? So let me minimize it. So this is the script. So I'll go back to my terminal and type Python, and then this is my script. Now before that, let me bring my okay. So you see the pings are working, right? So let me reduce the size of my Kali machine, and now notice something. The pings are going through. I'm going to issue the command, and for some time the ICMP pings will stop because the path to the root bridge has been manipulated, and it's now sending directly to the Kali machine. So as you can see now, the pings are failing, as you can see right here. So let me try a refresh, and as you can see, it will turn into problem loading page because the pings are failing. So you see, so we have re-engineered spanning tree. We captured spanning tree's own packet, re-engineered it, and then send it back into the network. And then the switch things, the Kali machine is the root, right? So now, basically, what we did is that we have manipulated the path to the root bridge, and then now all traffic is being sent here. So basically, this PC can't reach the WordPress server. So until the loop is done, the pings will not go through. So let me stop. Okay, now the loop is done. So now let's wait and see if the pings will go through. So it will take some time for spanning tree to converge. So let's be patient for a while. Let me try and refresh. My PC is slowing down, but that's fine. Okay, so it's still not working. Probably to work, so let's be patient. Pings will start basically. So let me try another refresh. Okay, so let's take some time. It will work. So let me check. Right. So now you see the spanning tree is where the spanning tree has converged, and now the pings are working because we are running a legacy mode of spanning tree. That's why it took some time to converge. So if we're using rapid spanning tree, the convergence rate will be very high. So that's thank you for watching this video. This is my first video on how to re-engineer some of our basic network protocols, and then harm networks, not to harm production networks, but I mean just for testing. So thank you for watching this video, and see you in my next video. Bye bye.